Okay, welcome back. We are working on perfect square trinomials and how to factor them, how to break them down to their most essential ingredients. And let's see how we do. So the work that I want to see is the following. Right above 16, you can write 4, because 4 times 4 gives me the 16. Right above the 25, you're going to write 5, because 5 times 5. Go ahead and multiply those two numbers in black together to give you 20, and go ahead and double it. It's looking like it fits what we want a perfect square trinomial to be, where we have a perfect square in both the front and the back, and we double the middle term. But we know we would need negative 20 and an additional negative 20 to give us negative 40. So we know there's going to be negative signs involved. So let's set up our parentheses. We can put our negatives right in right away if you want. Negative times a negative would give me that positive. So we have 4p and another 4p and 5 times 5. And that, my friends, is your answer. Notice, you could write the answer like this, because we have two of the exact same things. It doesn't matter which way you write it. Your teachers will like both ways. And then, of course, you could multiply it out and check your answer if you were feeling uncomfortable. Let's look at number 12. 4 times 4 is 16. 3 times 3 is 9. 4 times 3 is 12. Let's double it. Yeah, we definitely get 24, but we wouldn't get a positive 24. So it would have to be a negative 12 and another negative 12 to give us negative 24. So let's go ahead and factor. Set up our parentheses. 4x times 4x would give me that 16x squared in the front. 3 times 3 would give me the 9 in the back. And you only have 3 options here. They're both plus, they're both minus, or they're mixed. And we know they can't be mixed signs because that would be a difference of squares, because that would be conjugate binomials. And in this case, we can see it's negative times a negative, and we can do a quick check. Negative 3 times another negative 3 is positive 9. Check. Negative 12 in the middle, another negative 12 here to give us negative 24. And that's your answer. You could also write your answer this way if you wanted to. Okay, let's move on to question number 13 and 14. Here we go. I'm looking at two perfect square trinomials. How can I tell? Perfect squares, front and back. That's 2, that's 7. 2 times 7 is 14, and double that, I do get 28. 3 and 4, 3 times 4 is 12, and if I double it, I get 24. These look perfectly like perfect square trinomials. So that's 2, that's 7. 2 times 7 is 14, and if I double it, I do get that 28 in the middle. So it's meeting the requirements of a perfect square trinomial. So let me set up my parentheses. 2 times 2 is the 4 in the front. 7 times 7 is the 49 in the back. N times n gives me that n squared. And my signs are going to be both negatives. Negative 7 times another negative 7 is positive 49. Check. Negative 14 and another negative 14 is negative 28. So that does make sense. Let's try question 14. Perfect square, yes. Perfect square, yes. 3, 4. 3 times 4 is 12. Let me double it. If they were both positive, I'd get a positive 24 when I add them. So these must both be negative, so I can get a negative 24. So we have 3x times 3x is 9x squared. We're going to have 4 times 4 gives me the 16 in the back, and they're both going to be negative. All of this is the work I want to see. This is your final answer, or if you want to write it as a square, that's okay too. Great. Last two questions on your notes are 15 and 16. So we have 2, we have 1. We have a perfect square trinomial. 2 times 1 is 2. Let me double that and see what we get. We do get 4. If I add 2 plus 2, I get 4, but we know they're going to be negatives. So let's go ahead and factor. 2x times 2x. 1 times 1 gives me the 1 in the back. And they're both going to be negative. And if you wanted to write your answer out as a square, that's perfect too. Either one of these you can write as your answer. And if you're using Photomath, don't. I want to see all of this work to prove yourself. If I don't see the work, I can't give you credit. So please show your work. And last but not least, we have this beautiful, perfect square trinomial. 7, that's 3. 7 times 3 is 21. 7 times 3 is 21. We doubled it. But if I add 21 and 21, I get a positive 42, which is not what I have in the middle. So both of these must be negative to give me the negative 42. So it's 7 times 7, x times x. On the FOIL, these multiply to give you the front. 3 times 3 gives me that 9 in the back, but I know they're going to be double negative. So this is your answer. You're done. You showed all the work needed to prove that you actually did your work, or you could, of course, write your answer this way. Happy trails. See you guys later. Bye.